In this lesson we'll see Lamby's theorem and its use. To begin with, let us consider we have one object as shown over here. This is one object onto which two forces are acting. One force as shown over here is represented as P bar and another force Q. Both of them are meeting at a point. Since they are meeting at a point, we can complete the parallelogram as shown here and find their resultant. The resultant is given by the diagonal of the parallelogram, okay, which we represent by, let us say, R. Okay, by definition of resultant is that single force which will produce the same effect as the applied forces P and Q. So we can say that this situation is identical to the object, same object on which only one force, namely the resultant, is acting. Okay, so whether we say that two forces P bar and Q bar are acting on the object, or whether we say just one force R bar is acting on the object, it is the same. Of course, we need to maintain the same angle as shown at both these places. This fact we can represent on a force polygon, which we have already seen as shown here. You have a force P bar, and then from the head of P bar you draw a force Q bar, and then you form the closing side. This closing side will be the resultant of the two forces P bar and Q bar. Now let us see a slightly different situation. Let us see we have a situation in which you have the same object on which the force R bar is acting. The same force R bar is acting. Let me try to draw it in correct color. The same force R bar is acting on it, and along with this you apply another force at the same point, that is the point of application of the new force is the same and opposite in direction, okay, and equal in magnitude. This force, let us say we represent it as R reverse, okay, because these are two forces, okay, equal in magnitude, opposite in direction and collinear. These two will keep the body in equilibrium. Okay, there is an axiom to show that. Here we'll do a little trick. We will now replace this R bar with P and Q, because we saw whether we say resultant R bar is applying or whether we say that forces P and Q are applying on the object, the effect is really the same. So we'll try to draw this object here, and then we'll try to draw the two forces P bar and Q bar. Okay, this is P bar and this is Q bar, and also will show the force R bar. The situation is really the same. All we have done is replace this force R bar with P and Q, which is permissible by the definition of the resultant. So these forces P bar, Q bar and R reverse, they are keeping the body in equilibrium. And if we try to draw the force polygon, you have one force P bar, from the head of which you're trying to draw another force Q bar, and from the head of which you'll be drawing another force R reverse. This force is R reverse. So this is forming a closed triangle. That is, you can see one force is going from O to A to B, and then back B to O. It is forming a closed triangle. Because this is in equilibrium, this is in equilibrium, we'll say that this forces forming closed triangle, they are in equilibrium. Okay, the point we take home is that if you have three forces, P bar, Q bar and R reverse as shown over here, they are in equilibrium. In fact, we can see that this triangle force, this force triangle, which more or less forms the basis for us to come to the conclusion that if the forces form a closed triangle, they are in equilibrium, it comes from the parallelogram law itself. For example, you are showing that the resultant R is formed as shown over here. Okay, in fact, within this parallelogram you can see a triangle. I'll try to draw it in very thick line. This is one force P bar, and this is one force Q bar, and the resultant R bar. Because this parallelogram law is true, and within which you see a triangle, this must also be true. So when you have a closed triangle force polygon, the body is in equilibrium provided the forces P bar, Q bar and R bar, they meet at a point as shown here. That is a necessary condition. You have all the three forces meeting at one point. They are coplanar concurrent forces. In fact, you can extend this to any number of forces. Let us say you have a force F1, okay, and you have a force F2, and this force F2 is drawn from the head of force F1, and then again from the head of F2 you draw a force F3. From the head of F3 you draw a force F4. From the head of F4 you draw force F5. Okay, if all these forces F1, F2, F3, F4, F5, they are coplanar and they are concurrent, and if they form a closed polygon as shown here, then these forces, they are in equilibrium. Okay, in particular we are interested in the triangle, so let us try to draw the triangle of forces. Let us say this is force P, and from the head of P we try to draw another force Q, and from the head of Q we draw the next force R. Okay, if this PQR are coplanar forces and they are meeting at a point, and when we draw the force diagram, if they form closed triangle, they are in equilibrium. Okay, further, if you take this angle to be alpha, if you take this angle to be beta, and if you take this angle to be gamma, by sine rule for the triangle we see that magnitude of the force P bar by sine alpha is equal to magnitude of the force Q by sine beta, is equal to magnitude of the force R by sine gamma. Okay, this rule is also called Lamby's theorem. And this Lamby's theorem in general is applicable in situations where you have an object on which three coplanar concurrent forces are acting. One is this force, let us say another is this force, and another is this force. Okay, you have to carefully note that all the three forces are coplanar, they are meeting at a point, and they are all directed away from the point of application. Let us say one force is P, another force is Q, another force is R, and if you take the angles, this angle, okay, between Q and R is alpha, and then this angle is beta, and this angle is gamma. Then Lamby's theorem says that P by sine alpha is Q by sine beta is R by sine gamma if these are if the forces keep the body in equilibrium. Okay, this Lamby's theorem is useful in situations where you have three forces. The three forces are concurrent, they lie in same plane, and you know magnitude of one force and you know angles alpha, beta and gamma. Then you can find the magnitudes of other forces Q and R, okay, provided you know the magnitude of one force P. So if you know the value of magnitude of force P and the angles alpha, beta and gamma, you can find the magnitudes of other forces Q and R to keep the body in equilibrium. Okay, we'll try to see more about how to use this Lamby's theorem using several problems as examples in subsequent lessons.